Hey everyone, welcome back to the channel. This is FrSky Steve. Today we're talking about an exciting topic. This is collegiate RC plane competition and the suggested electronics for them. Now, for the average hobbyist, you're like, hey, what's happened with FrSky Steve? He usually has great tips and tricks, and all of a sudden we're talking to college students. If you stick around, you might learn some things about the college students, what they're up to. It's really exciting stuff, and this is, I think, great for the whole RC community. So, what are these flying competitions I talk about? And there's a couple of them that are put out. One is by AIAA, another one is SAE. And so, every year, these large international organizations put out a challenge to all the different universities around the world, saying, show up to a flying field. Most of the times, that the ones that we're focused on with SAE and AIAA are in the United States. So you show up these flying fields in the United States, and they give a list of specifications about what a plane should do, what the mission is, and there's just a number of limitations on this, and it is mind-boggling how difficult this is. You have to have a plane fly for 5 minutes, or it has to perform certain tasks. And because of this, this is really something that separates people. I mean, this is taking book education and applying it to aviation. We're applying it to model aviation. And because of that, that's something that interests us as hobbyists as well. The photo you see here is actually an SAE competition, and this was not at all set up. This was actual them. You see how engaged they are into this? This is what happens. You get hundreds and hundreds of college students who show up to these events, and they're so excited. They do this for a hobby. This is something that they do. They get no college credit for it. All they get to do is they get to represent their college, and they end up oftentimes paying out of pocket to go to these events. So this is where they take book education, apply it to model aviation, and you know what aviation is like. The best laid schemes sometimes, I mean, they can have the flight of a lifetime, and if the plane crashes on landing, they get nothing. And so it is high stakes, it is exciting, and a lot of times the people who end up flying these planes for the colleges, some of them are college students, they fall in love with model aviation, and they continue on after college at our field and join our community. So we very much want to support the colleges, and I did make this pledge that I will tell you this, to the college students, these flying fields, I've been to so many of them around the United States. Excellent people who are good, hardworking people, very honest, very friendly. They will help you out. Some fields are better than others, and if you have a bad experience, now occasionally you'll run across somebody who's old and disgruntled, and we just kind of have to smile them off. But if you have a bad experience, please message me. This is for North America, fields that are part of the AMA. Please message me. That my email is at the end of the. I will forward it on to appropriate leaders in the AMA, and people will have a talking to, because they're very passionate about seeing young people showing up to their flying fields, and we all want to make sure you have a great experience. So what I'm going to talk about is collegiate hardware telemetry suite. This is something that I think that's could be good not only for one type of competition, but for all these different competitions and for years to come. And this is a video that's created for a lot of these college students. You look at the team, only a few people on the team fly, maybe one or two at the most. Some of them have nobody who flies, and they have to have alumni or just people in their local community fly the planes for them. But what happens is there's a lot of decision makers, and I'm going to try to keep this as simple as possible without getting into too much jargon. And if you need more information on any specific topic, there's online manuals and videos. You just search for FrSky and Ethos, and in whatever topics, such as how to register and bind your receiver, you'll find lots of information out there. This video is for modern FrSky Ethos-based transmitters only. Those are the tandem and twin transmitters, things like X14, X18, X20, X20 Pros, all these things, right? We have these older transmitters like the X9Ds and QX7s, which are still great transmitters, but unfortunately the computer technology in those radio systems and the operating systems are not up to snuff. It doesn't do all the things that we want them to do, that we're going to really want to use as far as competition is concerned. So, and just as I told you we're not getting the weeds, here's something that gets us in the weeds, and I'll try to keep this as brief as possible. Essentially what happens is there's something called EthoSuite. It's a free piece of software that you download, and what you can do is put it on your computer, and when it's installed you can plug your transmitter in. It's going to scan your transmitter, and it's going to identify your transmitter, and it's going to look and see what's out of date on it. Is there newer firmware? Is there a newer operating system? Is there a newer bootloader? It goes through and it will help you install all of this. It's pretty straightforward and simple. So getting a transmitter updated is not horribly difficult. The one thing I will point out is that we had a huge major update in end of 2024, and so we need to make sure we have the internal module be on version 3.0 something or higher, and also the firmware for the receivers needs to be that as well. And what this means is that you can go through and you can register and bind your receiver, and all of a sudden, you know, you will start to see your control surfaces work, and you're like, hey, great, this is working fine. Yet, when you look at the top of the transmitter, when you see the 2.4 gigahertz and 900 megahertz, it's showing 0, or it's showing no signal whatsoever. What that means is you have old firmware on your receiver. You need to do an update. There's something called an over-the-air update. It's a process you need to follow, and then also doing a couple factory resets, and you should be good to go. This should take you about a half an hour to get this done. Some of the newer receivers coming out don't even need this anymore, but still there's some of them that do, so that's the telltale sign is when you're not seeing this. The reason why this is important is because everything we build on in this video and the next video is based on telemetry, and if you're not getting the updated firmware for your receiver, you're not going to see the telemetry, and you will not be able to take advantage of all the cool things that it can do. Okay, now we're going to start talking about hardware. We're going to start off talking about transmitters, and we're going to start off talking about the tandem transmitters. It's very hard for me to really talk about this in a brief thing because this is such a significant investment for a lot of people that they want to know all there is to know about it. What I can do is give you enough information to tell you why these things are truly special. This is a tandem-based transmitter. This X18 is the entry level to it. It's a great transmitter for a lot of colleges to start off with. What I will say is that this is the first real transmitter in the new era of transmitters. There's a lot of yesterday's technology for sale right now. A lot of it gets makeovers done and a lot of hoopla around it, but essentially this one is so different. The reason why it's different was because around 2020 we decided that we wanted to make a transmitter based on the H7 microcontroller, which was state of the art. It's going to be something that's going to be around for a very long period of time. In order to really take advantage of it, we had to rewrite the code base, and that required us from start to finish to create a new operating system. That operating system was known as Ethos. We designed this in such a way that it took the smartphone technology or simplicity of a smartphone. You know, we touch and scroll and do things like that. We brought that to a transmitter, and that makes that really a neat experience. And because of this, you think like, okay, that's pretty cool, but you know, its operating system is robust and it can do a lot of things, and it's designed for the future. It's not going to be something that's going to go obsolete in a year or two from now. However, that's not enough for me. I need more stuff to make this an easier decision. So the thing that a lot of people look at when they move to the FrSky system is our control link, and that is something that a lot of people don't pay attention to until one of their favorite planes loses radio contact, and it is the worst feeling in the world to watch your plane crumble into the ground because you lost radio contact. And that's something that happens quite a bit because 2.4 gigahertz FSK is just essentially that band is saturated with a lot of different things. And for a variety of reasons, you can be flying 1 second and not flying the next second. And with that, we have something known as 900 megahertz. That is a great long range band. And if 2.4 gigahertz goes away, even for a very short period of time, 900 megahertz takes over, even if it's for a split second. And because of that, you have a much superior control link. This is the reason why a lot of people move to FrSky. It's the control link. They love it. Once they get into the Ethos operating system and they start to figure out all the cool things they can do, they love it even more. But the thing that we look at for college competition is the telemetry, the ability for it to do a lot of different things. These transmitters are touchscreen. They're full color. You can put the photo of your model onto the transmitter. They're using Ethos Suite. Touchscreen, as I mentioned before. Hall sensor gimbals, which means that when you are using these gimbals, you're not using something that has brushes in it, so it's not going to wear out over time. Because of that, these things are robust and they tend to stick around for many, many years. For a lot of people, this was their entry gateway drug into the FrSky operating system and the whole, I should say, the whole FrSky ecosystem. We have essentially the identical transmitter. It has a brighter screen. It has a higher resolution screen. It has more color choices. It still has the plastic gimbals. It's known as the X18R. Why would you spend more for that? It's because it has a third protocol, twin. So occasionally people have a lot of planes with old servos, and sometimes colleges get these older style servos donated to them, or maybe that's what they have laying around. And every once in a while, we have a problem with telemetry on 900 megahertz. And because of that, if you have one of these transmitters, what we do is switch you over to a twin-based receiver, which is 2.4 gigahertz FSK and 2.4 gigahertz long range, and this problem gets resolved. So this is $420 to $440 manufacturer's suggested retail price. That's US dollars. And now we're going to talk about the same technology, same everything that we just discussed a moment ago, same colors, but these have nicer 10-ball bearing CNC gimbals. As you can see, there's about $100 difference, $420 to $440, $520 to $540, $100 difference between them for these nicer gimbals. A lot of people love these gimbals. It feels great for maybe college competitions. A lot of times they don't have the budget to fork over the extra $100. They're fine with the R gimbals. The last in the series of transmitters that we're talking about is going to be this X20R and X20RS transmitter. This is a larger transmitter, so physically it's a larger transmitter in your hands. It feels great. It's a great size. The screen is larger, and that's one of the main selling points of the transmitter is that larger screen. It's easier to program at the field. It's very visible, great all-around size. You can see that the price difference between the X20R and the X20RS is $150 as opposed to $100, which it normally is. That's because this doesn't have just S gimbals. These gimbals are also shaker sticks. We borrowed this from the more expensive X20 Pro, which starts off at $1,000 for that transmitter. This one, what it will do is, for example, you're at a flying competition. Let's say it's a windy competition, and the thing you want to worry about is maintaining speed above stall speed. Shouldn't be a problem when you're flying, but it will be a problem when you're landing, and sometimes a gust comes along and you can't determine it. When you're coming in for landing, everything looks good, but what will happen is if you go below stall speed, the plane will slow down. Oftentimes what we'll do is we'll roll over and crash, and that'll be the end of it. So we don't want that to happen. We use an airspeed sensor to let you know when that you're, what your speed is. You're coming in for landing, and also to let you know when you hit stall speed. So you can set up a logical condition. You can have a voice yell out, stall, stall, stall. If you don't hear that voice, the gimbals can actually vibrate. And so imagine coming in, it's loud, you can't hear the stall being yelled out, but all of a sudden, you start to feel it in your left gimbal, like, hey, I'm below stall speed. And you just know to take that gimbal and speed up a little bit, and the problem is averted. So all around, a great little tool to have. It's a great investment. This radio system might, if you have the budget for it, yeah, it's great to get one of these X20RS. It's one and done. You can enjoy this for many, many, many more years. However, a lot of colleges will start off the X18 and they'll move up to the X20R and RS as they really get into the whole ecosystem of FrSky. Okay, now we're going to get into telemetry hardware. As you can see, there's a bunch of SKUs, a bunch of prices. I'm going to describe what each one of these things does briefly, because in a moment we're going to discuss them in greater detail. So FLVS determines how much power you still have left in your battery from the balance port. And the PAS70 is an airspeed sensor. The FAS 150 is actually a current sensor, and you know what a GPS module does. So you can see the prices on everything right here. Not horribly expensive for any of these things. Absolutely worthwhile. I will have another video describing how to set these things up. But in the meantime, let's move on to the next topic. We are going to talk about receivers now. And essentially, I'm going to talk about stabilized receivers for a brief moment here. Why would you want one in a plane when you could not use it for competition? It's because they actually measure the pitch and roll angles. So if you're really honing in on your telemetry, you might want to use that, even though you cannot use the stabilization function in your flight competition. What you can do is you can use this for research and to determine, maybe it can help you out when you look at telemetry, knowing what direction the plane was going with the GPS module, but also knowing how far the plane was rolling or pitching while looking at specific points of telemetry information. So we have the TD SR18 for about $145 MSRP US, and the same thing without the stabilization is $105. These are interesting because they have XT30 ports on there, and what you can do is you can plug your batteries into it, 2S batteries, if you have 8.4 volt servos. And what that will do is it will power up to 30 amps continuously and peak 60 amps. So great stuff. The TD-R10 and TD-SR10s do not have the XT30 connectors on there. They're 10 channels opposed to 18. As you can see, there's $60 for the TD-R10, which is a great all-around receiver. It's my go-to receiver. We sell tons of these receivers. They're beloved. The TD-SR10 allows you to have stabilization, but it does not give you the battery ports. We also have servos. Our servos are the MB5301H. This is one that we have a lot of different servos, but this is the one that probably makes a lot of sense for a flying competition, simply because it's very robust. And for what it is, it's horribly inexpensive. This is a beloved servo. This is our best-selling SKU. If you ask me what do we sell the most of in North America, what one item, it's this item right here. Okay, so let's talk about all these sensors now, because this is what you came for. FLVS is a battery checker, the best way to describe it. You know, when you're flying RC and you're at the flying field And before your flight, you check your battery to make sure it has enough power. And then a lot of times after your flight, you check to see if you drained it too much or if you came in too soon. What this does is the exact same thing. It hooks up to your balance port on your battery, but it will let you know in real time how much power you have. It does it for pack voltage and also for average cell voltage. So really fantastic stuff. You can keep track of things. You can also use this to help you determine if you're drawing too much power, or maybe you're down to the last couple laps and you can look and see, you got plenty of power left. Why don't we open up the plane and get as many points as possible? So, a great thing to have. It is pretty light. It's about 1/4 of an ounce. This comes with the screen. We also have a version without a screen as well. And they set up with FBus. It's hard to tell, but there's actually here on the pins, there's another set of pins right below it. And what happens is you can take and plug one set of pins into your receiver on an FBus port, and then you can keep plugging in other things to this. So, for example, you can plug a GPS into there or an airspeed sensor, and you could daisy chain them. So, on one port, you can have all 4 of these telemetry modules on there. The next one is the PAS-70. This is an airspeed sensor. These things are good for up to 167.7 miles per hour. I know you think your plane flies fast. Most of these collegiate competition planes will never get anywhere close to 167 miles per hour. Thus, you do not need the PAS-100 telemetry module because it's really not needed. This is fine for what it is. They're horribly inexpensive too. I mean, this is a great deal. There's a lot of manufacturers of radio transmitters that don't even have this option. So it's a great thing to have. This is, I think, one of the most crucial things you should have on a competition plane, simply because, especially in environments where it's windy, you want to make sure that you have control of your plane at all times and you stay above stall speed. And this becomes extra crucial when you come in for landing. I mentioned before this entire shaker stick technology. This does it. This will help you with the combination with X20 RS. You can get that shaker stick technology and you can avoid having crashes. This also will work with radios like the X18. And instead of having a shaker stick, you just have an audio call out and listen for it. Or you can set up a whole radio shake on there as well. Instead of having the gimbal shake, the whole radio will vibrate, let you know when you're getting close to stall speed. So a lot of different options here. This is the current sensor. What you need to do is take especially from the wires that come to your ESC, and run them through that hole in the center right here. And the idea is it can measure up to 150 amps, which is greater than I believe that you possibly be using in a collegiate competition. So not really going to be an issue. This is all you really need. You can see, I was getting a kick out of this, that it works anywhere from negative 67 degrees to 482 degrees. And GPS, I know people think, well, I don't need a GPS module. What can it do for me? Essentially, it does a lot more than what people think. So aside from location, it will keep track of time. It does keep track of your altitude as well, and the direction your plane is going, and your ground speed. So if for one reason or another you can't hook up an airspeed sensor, this will also help out determine the speed as you're coming in for a landing. Ground speed is different from airspeed. It's the amount of speed you have moving over ground. If you have a plane that's doing, let's say, 300 knots pointing straight towards the ground, and it is not moving horizontally across the ground, but it is going straight down vertically, it's going to measure ground speed as 0, where the airspeed is really 300 knots. So something to keep in mind. This is an all-around. They're fairly inexpensive, and It's just something else to have on your plane that keeps track of. It's like a second way of checking to see, uh, keeping track of how accurate your airspeed sensor is as well. In another video, I'll show you how to modify that if you need to. And last, we're going to talk about servos. So our servos measure voltage, temperature, and current. These AX servos are exact servos. They do things such as, they have some really neat features about them. They're high torque, they're extremely quiet, they're extremely fast. They have robust metal gear design. They are digital. They have soft start technology. What that means is that when you plug in your plane for the first time and maybe your ailerons are down and up, instead of jumping back into their center position, they do it slowly so it does not stress out your control surfaces. There are cordless motor designs on these, and the thing about it is, if you look at this one, this MD5301, there's a reason why I focus on this one. It does 374 ounce-inch of torque at 8.4 volts, which is 2S. I suggest using 2S to power your planes. 0.06, so they're extremely fast for a 60-degree sweep. They're F-bus, so they give all that great telemetry I was just talking about. And they're aluminum CNC machine case, and they have really nice dual precision ball bearing with Hall sensor inside. So a great all around, it's just fantastic. Supports overcurrent and overhot monitor. So that was the whole thing about measuring temperature. And you can update the firmware, but usually you don't have to do that. With all that being said, I've discussed quite a bit, and I do thank you for watching today. My name is FrSky Steve. I'm Steve Schlesinger. That's my email address. That's our website as well, FrSky-RC.com. There's also another part of the website called ethos.freesky-rc.com with all sorts of information about Ethos. I have a document, it's bit.ly/FrSky info that talks about all. It's a good introduction to FrSky. I work for FrSky Electronics based in Wuxi, China. I work in the North American division in Brea, California. And above anything else, I am here to help. This is me with the University of Alberta. This was the SAE competition. Really friendly bunch of people. I enjoyed them. Really into this whole collegiate competition, and please feel free to reach out to me if you have any questions. I am here to help. Thanks for watching. 3, 2, 1.